Good morning, students. In the transportation engineering lecture series, today we are going to discuss about our third chapter, that is highway materials. In that, we are going to discuss about the three major highway materials which are used for the construction. And the first is soil, second, bitumen, that is one of the binder materials. Tar, asphalt, bitumen are the binder materials, and the aggregates. In this highway material chapter, we are going to discuss about three major construction materials, that is soil, bitumen, and aggregate. Okay, so let's start with the first, soil. Soil is the main constituent in subgrade and embankment. Aggregates are used in the subbase and subbase layer, aggregates and binding material in the top layer. Subgrade and embankment provides support for the pavement. Different types of failures such as rooting and shoving in the flexible pavements, cracking in the rigid, that is concrete pavements, are due to poor subgrade soil. Okay, so what is mean by soil, and we are going to discuss about different tests which are carried out on the soil, and the classification of soil we are going to discuss in this lecture. So, soil accumulation or deposit of earth material formed by the disintegration of rocks. Then, desirable properties of soils. Soils should have following properties: stability, incompressibility, permanency of strength, minimum change in volume, good drainage, ease of compaction. These properties are most desirable. Then index properties of soil. Index properties of soil. The soil properties based on which identification and classification are done are known as index properties. The properties based on which identification and classification are done are known as index properties. First, grain size distribution, liquid limit, and plasticity index. First, grain size distribution is determined by mechanical analysis and liquid limit by Casgarand apparatus. Okay. Grain size distribution. Coarse grained soils by sieve analysis. For non-cohesive soils, sieving material successively through smaller sieves, and for cohesive soils, wet sieve analysis has been done. Okay. Soil fines by sedimentation analysis, hydrometer method, and pipette method. And gradation characteristics can be obtained, that is proportion of different soils, that is sand, gravel, silt, clay, etc., can be found out. Okay, this is the grain size distribution. Then you can see from the graph grain size distribution curves for different materials such as gravel, sand, fines. Mechanical analysis graph has been shown, and grain size in millimeters. Okay. Consistency limits and indices. Consistency limits and indices. Atterberg limits are the limits of water content used to define soil behavior. Behavioral conditions: viscous liquid state, plastic state, semi-solid state, and solid state. These are the four conditions, behavior conditions. And in left side, increasing water content and becoming weaker, and where in right side, liquid limit, that is plastic index, plastic limit, shrinkage limit, dry limit has been shown. Okay, these are the conditions. Then soil types. Soil based on the particle size and properties, different types are there. Classification is primarily based upon grain size distribution and index properties, but the soil types based on the grain size soils are classified as below: gravel, sand, silt, clay, etc. Then different systems of classifications. USGC, that is Unified Soil Granular Systems. Textural soil classification. Burmester method. Casgrande soil classification. Unified soil classification system. Yeah, that is USCS. Then BIS system, HRB system, and a lot more. But all classification do not have a common sizes for defining soil class. Okay, these are the different systems of classifications. Then let's start with the unified soil classification, that is USC. That USC, that is Unified Soil Classification, developed by Casgrande in 1948. Airfield construction, that is World War II, modified to suit the requirement of other constructions. According to USCS, that is Unified Soil Classification System, there are two types: coarse grained soils, which is greater than grain size distribution more than 50% retained on 75 microns, and fine grained soils, that is greater than plasticity characteristics more than 50% passes through 75 microns. Okay, then USC system. USC, Unified Soil Classification System. First, gravel more than 50% on sieve number 4, that is 4.75 mm. Then second, sand more than 50% passes sieve number 4, that is 4.75 micron. Coarse granular contains less than 5% fines, well graded, that is. Then poorly graded. Then for more than 12% fines, GM, GC, SM, etc. Okay, for fine grained soils, liquid limit is 50% or less, and ML and SL, etc. soil of low compressibility, MH and SH, etc. liquid limit more than 50%, soil of high compressibility. Highly organic soils are termed as peat. Okay, this is about unified soil classification system. In the table you can see Unified Soil Classification System from ASTM 2487. Major divisions and typical names. We are already in seen above PPTs. Coarse granular soils, that is more than 50% retained on 0.075 mm. Sieve, that is gravels and sands, and the names GW, that is well graded gravels, and well gravel sand mixtures, little or no fines, such like that GP, GM, GC, SW, SP, SM, SC, ML, CL, OL, MH, CH, DH, OH, PH, PT. These are the classifications. Highly organic soils, fine grained soils, coarse grained soils, and fine grained soils, silt and clay, etc. shown in table. Then Indian Standard Soil Classification, that is ISSC, similar to USCS, Indian Standard Soil Classification. Difference is with respect to fine grained soils, subdivided into three categories: low, medium, and high compressibility. Total 18 types of soils are there. Symbols used are same as USCS: clay, silt, sand. That is, sand is also further divided in three types: fine sand, medium sand, coarse sand, and gravel. These are the four major soil classifications: clay, silt, sand, and gravel. And the sizes are as 2 microns, 75 microns, 425 microns, 2.0 mm, 4.75 mm, etc. Then after classification, we are going to discuss about the what are the tests which are carried out on the soils. Okay, different tests are there for evaluating the properties of soil, strength and stiffness, etc. Studied. Shear tests, bearing tests, penetration tests are there to calculate the strength, stiffness, and the properties of soil. First, shear test. Shear test. This test is carried out on the small samples performed in the laboratory. Direct shear tests, triaxial compression test, unconfined compression test. These are some tests. Then bearing tests carried out on the subgrade soils. In situ test, load bearing area results vary with the properties of the soil under the test. Penetration test is a small scale bearing test. Penetration test is under the bearing test. Size of loaded area is small. Ratio of penetration to size of loaded area is large and can be in situ or laboratory. We can test the material. Then CBR test. CBR is nothing but the California Bearing Ratio test, which is developed by the California Division of Highway for classifying and evaluating the soil subgrade and base course materials for flexible pavements. It is an empirical test, cannot be related directly with the fundamental properties of the soils. It is also used to determine material properties for pavement design. This is all about the California Bearing Ratio. CBR denotes the measure of resistance to penetration of pavement material or soil of standard plunger under controlled conditions. Conducted in laboratory on remolded specimens. Undisturbed samples can also be used. Procedure for determining CBR value is standardized by various agencies including BIS. You can see in the graph CBR test setup. Here proving ring, plunger, dial gauge to measure penetration and the sizes pedestal of testing machine has been shown in the figure. This is all about the setup of CBR test. Plunger of 50 mm, 125 mm per minute penetration has been done. Load required for penetration of 2.5 mm and 5 mm are recorded. CBR value is expressed as the percentage of the standard load value in standard material. For 2.5 mm penetration, standard load is equal to 13070 kg and unit standard load is equal to 70 kg per centimeter square. For 50 penetration, standard load is equal to 2055 mm. Unit standard load is 105 kg per centimeter square. Then specimen in mold is compacted. This is the procedure of CBR test. Specimen in mold is compacted to maximum dry density. IS heavy compaction as per IS 2720 part 7 for heavy traffic roads. IS light compaction for low traffic roads. The specimen subjected to soaking for 4 days. Swelling and water absorptions are noted. Then weight is placed on the top of specimen in the mold and assembly is placed under the plunger of the loading crane. This is the procedure. You can see in the figure the graph showing penetration curves of CBR tests. The CBR value is calculated by using the relation CBR percentage is equal to load or pressure sustained by the specimen at 2.5 or 5.0 mm penetration divided by load or pressure sustained by standard aggregates at the corresponding penetration level into 100. Okay, you can see in the graph. Then reasons for initial concavity of shape. Top layer of the soaked soil is too soft after soaking. Top surface of the soil not even. Plunger is not vertical. Plunger arrangement is no. Wrong. Normally penetration value at 2.5 mm is higher than 5.0 mm and higher value is recorded as CBR, California Bearing Ratio. Average of 3 test specimens have to taken as the value. Presence of coarse grained particles results in poor reproducibility of results. Material passing through 20 mm sieves is only used in the tests. The next test is plate bearing test on the soil. We are going to discuss about. In this lecture we will discuss only the tests and the classification of soils. Okay, so let's start plate bearing test. What are the apparatus for the plate bearing tests are bearing plates, that is 750, 600, 450 and 300 mm diameter and 15 to 25 mm thickness. A load device consisting of hydraulic jack and proving ring arrangement or pressure gauge. A reaction frame for giving thrust to plates. Datum frame and dial gauges are used to measure settlement of loaded plates. Then what is the procedure for plate bearing test? Okay, so let's start. First, test site is labeled and plate is seated properly on the surface. Then for modulus of subgrade reaction of natural ground, topsoil up to 20 cm is removed. Then stiffening plates of decreasing diameter are placed and jack and proving ring assemble is fitted. Then 3 to 4 dial gauges are fixed on the periphery of plates. Then a pressure of 0.07 kg per centimeter square, that is 320 kg for 75 centimeter diameter plate, is applied and removed after few seconds. After that, dial readings are noted and corresponding to zero load applied by means of jack to cause a settlement of 0.25 mm. When no increase in settlement or when the rate is less than 0.025 mm per minute, the load dial reading and settlement readings are noted down. Average values are considered. Next, load is increased, so the settlement will be 0.25 mm extra. This way, experiment is repeated up to 175, up to 1.75 mm or more. This is the procedure. You can see in the graph, bearing pressure settlement curve has been shown. On the x-axis, mean settlement, which is in centimeter, and for y-axis, mean bearing pressure in kg per centimeter square has been shown. Then modulus of subgrade reaction is the reaction pressure sustained by the soil sample under a rigid plate of standard diameter per unit settlement measured at a specified pressure or settlement. IRC specifies that the K value of value be measured at 1.25 mm settlement. That's then K is equal to P divided by 0.125 kg per centimeter square per centimeter. Then allowance for worst subgrade moisture. Allowance for worst subgrade moisture. K value will be lowest at soaked conditions. Okay. Then moisture content during test may seldom represent worst condition at site. So K value obtained is modified by a factor to present the worst condition. Then two consolidation test specimens are prepared and one sample test in an soaked condition in lab, pressure deformation curve drawn, that is pressure for 0.125 mm is noted, and second specimen soaked. Then pressure required to produce same deformation is noted, that is PS. Then Ks is equal to K PS upon P. You can see in the graph two graphs has been shown, unsoaked specimen and soaked specimen. The graphs are different for different specimens. Then correction for smaller plate. In some cases, not possible to cause settlement of 0.175 centimeter for the diameter 75 plate. Smaller diameter plate will be used. Obtained K1 value is modified, assuming subgrade as an elastic medium where modulus of elasticity is delta is equal to 1.18 Pascal divided by E, but K is equal to P divided by delta, which is equal to E divided by 1.18 A. If E is constant for a soil, K is equal to K1AL equal to greater than K equal to K1AL divided by A. Okay, so thank you very much. In this lecture we are started heavier materials, in that soil aggregate and bituminous, that is binder materials, we are going to discuss about. And in this lecture we studied about the soil, classification of soil and the different tests which are carried out on the soil. Okay, thank you.